Hey guys, in today's video what we're going to do is we're going to be creating a missile commander, or missile command rather, and this is because I had not clicked on the screen. So we're going to be creating a missile command from scratch, and this is a preview of what that might look like. When you kill the incoming enemy, or if you kill multiple with the same bullet, get your bullet back. If you fire and you do not kill it, you don't get your bullet back. And so basically this is like best score. Right now the explosions on the ground don't really affect you. So that's basically the whole game here, okay? So you're just trying to get the highest score possible. And you want to do things like, if say there's two aliens coming out at the same time, kind of time it so that, or try to time it so that you get an extra bullet. Because if one bullet were to kill two enemies, you would get 2 extra bullets up here. And I guess this should be called missiles, and so we might actually change that. But yeah, so this is basically the game. So let's go ahead and start doing it. What we want to do is we probably want to start by creating the background, which is a star field. And so we'll start there, and then we'll work our way back to a fully fleshed game. Okay, so let's go ahead and let's see here. All right, so this is what we have in Notepad++, and if you're following in Notepad++, you're going to have a blank screen, or basically a blank document. And so what you'll want to do at this point is you'll want to go to File. Okay, so I have to put this out there. You might be hearing a lot of background noise. My wife showed up, and basically she said, I bought 6 chicks. And I was like, what are you talking about? And she's like, I bought 6 baby chickens. And she had them in a box. And so now they're almost old enough to go outside, but now they're staying in our sunroom temporarily. And our sunroom is where I do all my videos, and this is where I work from home and everything. So it is pretty awful. I'm constantly dealing with little chirps, and them pecking at the little cardboard and stuff like that. They're not running free or anything. They're in an enclosure, but it is a lot of noise. So hopefully you can bear with me through that. But let's go ahead and start this up. So we did File, Save As, and you can go ahead and save it as Missile Command. And then where you see this Save As Type, you want to go ahead and click on this and bring it down to Hypertext Markup Language. Okay, most of the programming that we'll do is going to be in JavaScript, and it's already there, so I just say yes. The start of the file is going to be HTML. And so I'm just going to bring those things in. Okay, these are things that are not really like, we don't really need to spend a lot of time programming out this logic. This is just, stuff that that's basically HTML. Well, except for what's inside the script. But this is very generic code right here. That just basically sets up our canvas so that we can draw on it. Okay, and so all HTML is going to go outside of the script tags. So this is HTML right here, and then so here from here to here is where all of our JavaScript code is going to go. And then elsewhere, this is all these other tags are going to be HTML. And we're not going to really worry about the HTML. But basically, this gives our canvas, this style right here gives our canvas some properties, such as a background color, the display margin, so forth. And that's basically it. That's all we're using it for. And then inside of this, and also one thing to note is this canvas tag right here. This is basically setting up the canvas, and here is where you can define its width and height. Okay, so if you have like a 14K or a 4K monitor, 14K, that'd be crazy, right? A 4K monitor, 800 by 400 may be very small. In fact, it kind of is. If we start it up, it starts off as a little little tiny block, and so this is actually zoomed in a lot. So this is 100%, and so this may not be what you want. You may want a screen that goes all the way to the edges, and that would be cool too. Okay. But otherwise, you could do it at 800, 600 and kind of scroll in, but things start to get a little blocky. It's up to you what you want to do with that. So what we want to do now is we are going to set up the star field, okay? And we probably want to take care of these since I went ahead and included them. So this document.add event listener, this is how you are going to interact with the canvas. Okay, so this is looking for a click, and this click handler is going to be coming from the mouse. And then here we have the mouse motion, and so this is going to get position on mouse move. Okay, so we're if you followed me through Zelda and even Street Fighter, we haven't done a whole lot of like mouse type event listening, but this is all mouse movement. Okay, and so let's look at this. We are right here, and we are going to go ahead and so we want to create that background. And so the first thing we want to do is the background is basically defined by stars. And so we want to create a star, kind of a template for a star. We can even call it a star class if you're used to other programming languages. And so in JavaScript, there are a few ways to do it, such as prototyping, but I just use the standard function star, and this star is going to have some properties. It's going to have an X and a Y, a radius, and a grayscale. And here we'll just set these properties up by saying this.x is equal to x, this.y is equal to y, this.g, this.r is equal to radius, this.g is equal to grayscale. Okay, so we have this star. And what I wanted to do now with this is I want to create an array to store lots of stars. Okay, And so that's going to be our very first variable. And so we're just going to say let stars equal this array. Okay. And we need to now populate this array with these stars. And so we're just going to create a for loop. Okay. We're going to say for let I is equal to 0 while I is less than star count, and then we'll say I. Now we don't also have star count, so we'll just go ahead and create that too, and we'll start out with 50. Now if you are choosing to use different dimensions here, 50 may be very sparse, and so you might want to up this to, you know, whatever, 200 or whatever. We'll see what 50 looks like, and then we'll adjust if we have to. So here we want to create stars inside this for loop. So what we're going to do is we are going to say we're going to create a random x, and we're going to give it a random value between 0 and 800. So 0 to 799 inclusive. And so we're going to say math.floor math.random times 800. Yep. And I'm going to copy this, paste. This is going to be the height, so it's going to be 600, and that's going to be rand y. And then this is going to be the radius. Okay, so this is going to be rand radius, and this is going to be math.floor times 3. And again, you can choose to play with these, and I want at least a radius of 1. So and then here is our grayscale. And so we want our grayscale to be on the lighter side. We don't want like an all the way like a 0, 0, 0 or a 20, 20, 20, because that's going to be like a really dark star, okay, and it may not even look right. And so we want a lighter star. So I'm going to start at 150. So we're going to say let GS for grayscale equal math.floor so times 156. So this gives us a value between 0 and 155, but we want to add 150 to it, and now we get a value between 150 and 255, and that is the range of colors on the RGB scale. So on the upper end, starting at 150. So that goes well for what we want. Now remember, a grayscale is basically where R, G, and B values are all the same values. So the red would be 50, the green would be 50, and the blue would be 50. Okay, so we're going to just push this star. And so we're going to say new star, rand x, rand y, radius. Okay, fantastic. So we have this, and it is populating these stars. But what don't we have? Well, we don't have the actual stars being drawn. Okay, so now we have this array with all these cool stars that we could go ahead and add, but we don't actually have the stars being drawn. So let's go ahead and do that. It's just going to be a simple, we'll create a new function. Let's see here. We'll call a function draw background. And And so we're gonna set the background to a darker color. So we're gonna do a ctx.fill style. And then we're gonna set it equal to RGB. And here we're gonna say 50, 50, 50. And then we're going to fill the rectangle of our screen with that color. And we're just going to do ctx.fillRect, which is fill rectangle, starting at 0, 0, and going for 800 by 600. And those chickens. And so here we are. We've created a darker background, and now we want to populate that star array. And so we're just going to say for let I equal 0 while I is less than stars.length I plus plus. Oops. And then what we want to do is ctx.fill style. And so this fill style is going to be that grayscale number typed into this. Okay, so it's basically going to be, we're going to create a string that mimics this string, but with the grayscale values here instead of just 50. Okay, so how we're going to do that is we're just going to say ctx.fillStyle is equal to RGB, open parenthesis, and then we're going to close that part of the string. We're going to add stars at i.g, and then we're going to add a comma inside a string. We're going to add this again, so I am just going to copy this, copy that, we're going to paste that there, and we're going to paste it there again. So this is going to say plus, and here this is going to be a closed parenthesis. And so yeah, we have plus, plus, plus. Okay, that looks great. And then what we're going to do, that just gives us the coloring, okay, of the star. And now what we're going to do is we're going to draw the star, and the star is just going to be an arc. So it's going to be a complete circle. And so we're going to do that by ctx.beginPath, which is going to tell us where to start drawing this arc. Then we're going to do a ctx_arc command. And if you're ever curious about any of these things, Mozilla makes some really good tutorial material for JavaScript, or you can just search BeginPath JavaScript, and it will basically, or arc JavaScript, and it'll explain all these things if I'm not doing a good enough job explaining them for you. So ctx_arc is going to have six parameters, and the first one is going to be the location of the center. Location of the center is going to be stars at i.x, stars at i.y. This is the radius of our arc, .arc. Oops. And then we are going to start at 0 and go around to 2 times math.pi. So that's a full rotation if we're thinking of it in radians. So and that makes a complete circle. If we wanted to make a semicircle, we could just do math.pi, and it would go and create a semicircle. But we're just going to create that full circle. And this false flag is for whether we want it to be counterclockwise or clockwise. We'll just say false. It doesn't matter because we're creating a full circle anyways. You could put true there. It would be the same thing. So that's the arc. And so this arc is basically it's not filled in. So it's just an arc. It doesn't have an outline. It doesn't have a filling. If we put this on the screen, we wouldn't see anything. So we want to fill it in with a color. And so we're going to ctx.fill. And then a ctx.close path. And then so we need to close our function here, our for loop. And so that closes our function. This is our for loop. And now we've come a long way. What we want to do is test this draw background. So I'm just going to copy this, and down here I'm going to invoke that function. Okay, so draw background. This is going to draw to our screen, and it's basically going to be a static image. So let's see here. We get an error. Let's see where this is. Click handler. Oh, all right. So we can easily take care of that. We're not quite ready to put in the click handler, and so I'm just going to comment out. Comment out these, oh Lord, these functions, or these statements, so that it does not look for a click handler and a get position method. Okay, so let's look at this now. All right, so here we have our star filled, and we can zoom in and make it slightly bigger. And in fact, maybe this is not enough stars. And so if that's not enough stars, we could easily go here and change that variable. And I would say maybe 125. And this looks, this looks good. It's a bit different than this one. If you want this even darker, maybe this doesn't look like deep space to you because it's pretty black there. So let's go ahead and change this to 20, 20, 20. And now this is looking pretty good. All right, so we have our star filled, and now what we want to do is we want to maybe create our player, which is going to be basically a cannon or something like that. That fires missiles, and it's just going to be sitting down here somewhere. Okay, and so for that we're going to need quite a few variables, okay, for our player. So up here we are going to start with so the first thing we need is player X and player Y. And we're actually going to need the image for the turret. The image for our turret is quite ugly, and you can change it in the future if you like. But how we're going to define our turret image is we're just going to say let turret equal new image. And this image is located in the files in the link below. So in the description of this video, you'll find a link to GitHub, and it's going to contain any necessary files, including the audio that you'll get later on. Okay, so that's the image. And now what we're going to do is we are going to define the source, and it is just sitting right there in our directory. PNG, and that is it. So now that we're going to start drawing things on the screen, we are going to need frames per second. So we're just going to say let FPS is equal to 60. I like 60. Then we need our player X and player Y, so player X is equal to 350. So this is going to be the width of our player. It's going to be 100. 150. And then we are going to be dealing with rotation of our turret. So we're just going to define what the current rotation is. So here we're going to say turret rot for rotation is equal to 180. And so that's that. Let's see here. If we are moving our mouse around to move this turret, we actually need that mouse X and mouse Y as well. So we're going to say let mouse X equal to 0. And so these things will change the second the mouse starts moving. So whether, who cares if it's 0, 0, because if I'm down here and I'm moving, it automatically becomes, 1,000 and, 800 or whatever. Okay. So what we want to do now is we want to draw the player. Okay. Now, this turret is, so our player, we want to draw trying to figure out the best way of explaining this. And actually, it's so late. I think I'm going to start this or continue on this video tomorrow. But this is going to be a all-in-one go. Okay, so this is going to be an all-encompassing video. It's going to go from start to finish. But I will start this again tomorrow. Okay, so we want to draw the player now, and let's go ahead and draw that player. So we're going to be drawing an image, and I believe we have the image here. We're also going to be rotating that image, and so we actually need a new function because we are rotating the image, and as it stands with just a regular the way we're drawing images, they're just like axis aligned, so they're like either just like straight up and down and left and right. And so we want to be able to draw that at any rotation. So we actually need another function before we get there. And so let's go ahead and throw that other function down here. And so this function, we're going to call this draw rotated, and it's going to take in an image, its X, its Y, its width, its height, and the degree of rotation. Okay? And so we are going to change the degrees into radians. And so here we're just going to say let rad or radians equal to the degree times math.pi divided by 180. And so that's just the conversion from degrees to radians. JavaScript, the translate or the rotate is in radians, so we have to think of things in radians. Now, for me, my head thinks in degrees. Like when I'm thinking of degrees of rotation, I'm not really thinking of radians of rotation. But, some people might, I don't know. I guess it really depends on your background. If you have a background in math, maybe you do think in radians. Okay, so what we're going to do is we're going to translate and rotate the canvas. So we translate and rotate the canvas, we draw the image on the canvas, and then we translate we rotate it and translate it back to its original position. So that's kind of what's happening. That's exactly what's happening here. So it's kind of it's not really intuitive. You're thinking, oh well, I'm going to rotate the image and then place it on the canvas. But what's actually happening is you're rotating the canvas and placing the image on that rotated canvas, and then rotating it back so that so that it looks like it did before we did. So we're just going to do a translate. So ctx.translate, and we're going to translate it at x plus the width divided by 2, and y plus the width, height divided by 2. Okay. And then we're going to rotate it by the amount of radians we said we're rotating. CTX dot. So this is the point of translation right here. And then we're going to rotate it about that point. Okay. So CTX. So this is the point of translation, and then we're going to rotate it around this point. So here CTX dot rotate, and that's going to rotate in radians. Then we're going to draw that image, ctx dot draw image, and it's going to take that image parameter we passed in, the width divided by 2 times a -1, the height divided by 2 times a -1, and the width and the height. Okay, so kind of just trust me with these numbers. And then to rotate it back, we're going to rotate it by a negative radians back. So that's basically going to get us to our start point. And so we're going to rotate by radians times -1. And then we're going to translate it. And so this translate is going to be the same thing, except we're going to multiply that. So I'm just going to go ahead and put parentheses around this part. And then we're going to multiply it by that -1 here. And I'm going to do the same thing here. Parentheses around this expression times -1, and close out that. Okay, so this is a big part of draw player, because without rotating we can't draw the player. Now, so let's get down to draw player. So function draw player. And so here we're going to take the adjusted x and y, because the adjusted x and y is how we're getting our turret rotation. Okay, and so it's telling us the points where we should be drawing our pictures. Okay, and so we're going to use a function called arctangent2. And if you're not familiar with it, go ahead and look it up. I believe it was created to make this process, just this process, easier of rotating images and stuff. But I think that's it. But I don't really know the history behind it. I don't think I ever used arctangent2 in a trig or geometry class that I ever took. So this is just something I learned quite a long time ago, and it was in relation to just graphics. Okay, computer graphics. Okay, so let's just go ahead and get this out. So we're going to get this adjusted x, and this adjusted x is going to be player x plus player y divided by 2 and minus 15 divided by 2. Okay. And so this is getting the center point of the on the x-axis of our image. Okay. And then what we're going to do is we're going to subtract where our mouse x is. So whatever that value is. And then we're going to do let adjusted y. Because this actually tells us, this allows us to rotate it around. This allows us to rotate it around that mouse x and mouse y. And so basically this is going to be the same thing. It's going to be player y plus player height divided by 2 minus, and I probably shouldn't have hard coded these out. Whenever possible, you should just use variables. But these are the width and height of that turret image. Okay, and then this is going to be mouse y. Okay, so now we're going to get the, and this is a typo. And so now what we're going to do is get that turret rotation. So here we're just going to say turret rotation, and it's going to be equal to a -1 times math dot atan2. That's that function we were just talking about. Adjusted x, adjusted y times 180 divided by math.pi plus 180. Now we do that plus 180 because math.pi actually starts, I believe, over here on the left hand side, and when we think about rotation in degrees, we think about it starting over here. So we're just adding 180 to that to get it to this side over here. So when it rotates, it starts where it should. All right, and so now what we want to do is we want to make sure that it cannot rotate behind itself. Okay, so we want to keep it with the rotation within the field of play. And so here we're just going to say if turret rotation is greater than 250, then we're going to say and then here we're just going to say if okay, and then we're just going to draw out our player and draw that image. Okay, so we're going to draw the base of the player, and so we're going to create a black background. So ctx.fill style, and it's just going to be black. Now there are some shortcut colors in JavaScript, and we could just say black right here. I like to keep it with RGB, so you can control it in the future if you do wish. And so this is going to be 0, 0, 0. So, but just saying equals black, I think there are like 32 predefined colors, whereas RGB gives you like 16 million or something like that. So, you know, just something to think about. And then we're going to draw that image, draw image, but we're going to use this new function that we created for ourselves. And so here we're going to draw the turret, player X plus player W divided by 2 minus 15 divided by 2. Okay, that's the center point of our image, and for the x-axis, and then for the y-axis it's going to be the same. So player Y minus 60 divided by 2. Okay. And then here we're just going to do 15 for the width, 60 for the height, and we want it to rotate by turret rotation amount. Okay. And then so here, that's our draw image. Draw image rotated, and then we're going to do our ctx.fillRect to draw that rectangle whose style we just defined. And so here we're just going to say player X, player Y, player width, player height. Yeah, looks good. So this is like the body, and then this is actually the I guess the cannon of the gun or whatever, the barrel or whatever, and this is the base. Okay. And so that draws the player and it rotates. Now, we may not have rotation done yet because we still have to draw in the controls, but we can see what this may look like. Now, what we're doing is drawing background right now by itself. I would like to go ahead and change that at this point. We can go ahead and flesh out our draw function so that it draws not just once, but it will continually draw. And so to do that, we already have our FPS right here. And so we're going to come down here and we're going to create our draw function. So we're going to do a set timeout function. So we're just going to say function draw. And then here we're going to do set time out. Okay, and inside this set timeout function, we're going to do a request we're going to draw that background that we already have. And then we're going to draw the player. Draw player. And so at the very end, so that's everything that we're going to have in there. So set timeout. See this set timeout, it starts right here, but we haven't ended it yet. Okay. So to end it, we're going to tell it how often to refresh. Okay. So this is the timeout of this function. So it's going to be 1,000 divided by our FPS. And so that ends that function right there. And now what we're going to do is we're going to get rid of this background, and we're going to call this function to get it started, and then this is going to continually loop through. So this is our animation, function. So it continually animates. And if you've seen my previous tutorials, you'll be very familiar with this. Okay, let's go ahead and see what this does. Hopefully it doesn't give us any errors. Okay, so right now we see the star filled, we see the player, but it doesn't do anything. Okay, so why is that? Well, let's go ahead and take a look. So let's pull that back up. So I'm thinking it has to do with this event listeners. So we don't even have our event listeners yet. They're commented out, but we're going to comment them in and go ahead and define these. Well, actually, we're just going to define this get position because this is all we need for right now. So this is the mouse move event listener. So whenever we move our mouse, it's going to trigger this and give us information that is going to pass into get position, which we do not have. So we want to go ahead and define that real quick. All right. And it's super easy. So here, right after we create our star field, we're just going to say function. and it's going to say get position E, and here this is where we're going to assign values to our mouse X and mouse Y. So this is going to be E dot X minus canvas dot offset left, and this is going to be mouse Y. It's E dot Y minus canvas dot offset top. Okay, so we have our get position now, and so now let's go ahead and run it, and let's hope that the turret is going to rotate. Now it does. There feels like some problem with it. Okay, so real quick, I see where we were going wrong. Just a typo on my part. So here we have player X and player Y. Why would we do player Y divided by 2 to get the center point of the x-axis? This should be player width divided by 2. And so now it should improve that responsiveness. So now it actually follows the mouse. Okay, and so this is what we want. And so the next thing we need to do is potentially start drawing some bullets. So let's go ahead and get straight into that. So here, let's go ahead and draw bullets. Actually, we can't draw bullets until we actually have a bullet to draw, if that makes sense. And so up here we have a function star, and this is similar to how we're going to do bullets. Okay, and so what we want is we want an array. So here we have like a star array. I like to keep all my arrays in one spot, but it doesn't really matter. And so I'm just going to say let bullets equal this. And then down here we need to create a bullet class. So function bullet. And so this bullet class is going to take in an X, a Y, a degree, a color, dest X, and dest Y. So this is the destination X and Y, because we are placing our mouse down, and wherever we click at is where the bullet should travel to. Okay, and then once it travels to that destination, it will then explode. So that's what we're going to be doing. And so what we want to do now is we want to say this dot X is equal to X. You know the drill. This dot Y is equal to Y. This dot DX is equal to dest X. This dot dy is equal to dest Y. This dot degree is equal to degree. This dot C okay, and so now we're going to define some variables that are not passed in. Okay, so this is just going to be this dot dist to travel. So this is the distance to travel from the end of our gun to the point on the our destination X and Y. And so here we're just going to use the distance formula. And so right there we're just going to say math dot square root dest X minus X times So basically it's this, again, copy, paste, and we're going to close it off. And then basically the same thing, so I'm just going to copy this right here. And so this is going to be a Y, Y. Okay, and so now we have this distance to travel variable. And you'll see how we'll use that here in a bit. So now we have a way of creating bullets. Okay, so now we have to go and actually create them. And so to create them, we're going to use our click handler. So this is going to be when we click the mouse, it's going to create our bullets. Okay, and so let's go ahead and go down to click handler, which we do not have yet. So here's our previous mouse function, and here we're just going to say click. It's going to take in that event. Now this is, I was just doing some, it should just be event.e, or event.e.x and e.y. Okay, so here we're going to have a variable. We don't want it to fire continuously because we only have 20 bullets, and if we hold the mouse down for even a second, you know, we're 16 bullets or 60 bullets are actually going to fire off, and we don't really want that. So what we're going to do is we're going to say if can fire, and then we're going to say fire to X, and we're going to define these variables in here in a second. Is equal to E dot X fire to Y is equal to event, E dot Y and then we're going to set is firing. So it's going to be, it's just going to tell it that it's firing, and this is where we want it to fire to. Okay, so now what we want to do is we have this if can fire, and so what we want to do is let's go ahead and add these variables up to the top. So why am I doing that? Let can fire equal to false. Let fire to X equal to 0. Let fire to Y equal to 0. Let is firing equal false. Okay, and so now we have this. This is basically a control for us. This is saying, can we fire if we, or I'm sorry, this is the control for us. If we are firing, we want something to happen. All right, and so another thing that we'll put up here, because I know we're about to need it, is we're going to say this is going to start us off with an initial amount of bullets that we can fire. Okay, so going down here, we're going to come down here to, it doesn't really matter, after any function, and we're going to create a function controls. Okay, and so here it's just going to be a single if statement. We're going to say if is firing and bullet amount is greater than 0. Now if this condition is true, we can go ahead and say can fire is equal to false. We want to turn off that thing. We want it to only shoot one bullet when we fire. We're going to say is firing is equal to false. We're going to set bullet amount minus minus. And then we're going to create these like turret X and turret Y calculations that tell us where on the turret we want the bullet to come from. Okay, so let turret X equal to, and this is going to be player X, player width divided by 2. And then I'm just going to go to the next line, make it easy to see. And then we're going to say 30 math.cosine and here we're going to say turret rotation plus 90 times math.pi divided by 180. Okay, so cosine is going to give us the x location from a center point to some point on the outside of a unit circle. Okay, if that makes sense. And so here we're figuring out where this turret X is based on this location. All right, and so we're going to do the same thing for turret Y, but that's just going to be a copy and paste. And just change these to Y. This is going to be height. This is turret rotation still. Now, cosine is X on a unit circle, and sine is Y on a unit circle. And so that looks good right there. Okay, and so one thing I did with these bullets just to make it a little bit more visually interesting is I changed the color of the bullet every time it shot. And so we're just going to keep that little mechanic. And this is just going to be math.floor, math.random times 256. And so R, G, and B are going to be the same thing. So copy paste. This is going to be a G. This is going to be a B. And then we're going to create the string. So RGB values in JavaScript, as we've seen before, they're in string form. Okay, and so here we're just going to say let RGB equal to. Now this is a lot of open and closed quotation marks, so we're just going to say RGB open parenthesis plus our R value plus a comma plus our G value plus a comma plus our B value plus a closing parenthesis. Okay, perfect. And so now we have everything we need to create a new bullet, and so we're just going to push a new bullet into our bullets array, adding that new bullet. And it's going to be turret X, turret Y, turret rotation, RGB string, fire to X, fire to Y, and that is fine. And so now what we want to do after we add a bullet, so this means that we fired a bullet, and so what we want to do is we want to create a sound, and that sound is just going to say and we'll create this function here in a second, play sound, and we're going to pass in turret fire dot wave. Now this is a free sound I found, but I don't know exactly where I got it. So but it was free to use, and it didn't require permissions to like acknowledge the author. Usually I do like to acknowledge the author when possible, but you know, it was a while ago and I didn't do that at that point. So this looks good. One thing, since we're doing it piecemeal as we go by, I want to go ahead and add this play sound. Okay, so here we're just going to create that function. Oops. Here we'll just do insert. Okay, so for play sound, it's actually, there's not much to it. We're going to create a sound. And then we're going to say sound.volume. And I don't think we need to do this because I think the volume actually starts off as 1. But in other games, I like, if there's like a cut scene or something like that, you might want to decrease the volume as you're going into a cut scene, or maybe there's background music and you want that volume to be, you know, at some volume. So I put that in there just so that you have an idea of what you can do with this. And there's so much you can still do with the sound. You can loop it, you can do all kinds of stuff. Definitely look into it if you're creating your own game and you want to mess with sound a little bit more than just playing a sound. Okay. So that's going to play our sound, and let's go ahead, and the only thing we have left to do here is we have these bullets, but we don't have any bullets showing up on the screen yet. So what we want to do now is do our draw bullets. Okay, so we're going to go right down here, create a new function called draw bullets. And we're just going to say bullet timer plus equals 1. And then we're going to say if bullet timer is greater than or equal to 20, we're going to say it can fire. So this is every 20 cycles you can fire a new bullet. So we're going to say can fire is equal to true. I guess every 20 frames drawn, I should say. And then we're going to say bullet timer is equal to 0 again. I'm just going to reset that. Okay, and now what we want to do is we want to draw the bullets. Okay, so here we're just going to say for let I equal bullets.length I plus plus. And here we're going to create a fill style because it is just a circle. We're just going to do CTX. And now we've already created the color, so all we have to do is call that property. So it's going to be bullets at I, so the bullet at that index within our array, and we're going to get the property by doing the dot notation, so dot C. All right, and so here we're going to say CTX dot begin path to create the beginning of our circle. We're going to do an arc. So an arc is just when it's a fully rotated arc, it's just going to be a complete circle. So CTX.arc, and where do we want that arc? Well, we want it at bullets at I. I'm just going to copy this because we'll use this quite a bit. So bullets at I dot X, bullets at I dot Y. It's going to be a radius of 4. It's going to start at 0 and go to 2 times math.pi. So a full rotation starting at 0 to 2 radians. And then counterclockwise or clockwise, that's that false. So it is not counterclockwise. I believe the false is, it basically it just flips it from clockwise to counterclockwise. And here we're just going to do ctx.fill, ctx.closePath. And then we're going to update our bullet x and y. So bullets at i.x is plus equal to math.cosine. Bullets at i.degree plus 90 times math.pi divided by 180, converting to radians, times 15, which is going to be our bullet speed. Okay, so this is basically the magnitude of this this change here. I guess this would be a vector, and so there's a this is the magnitude of adding the cosine value of this degree. And here I see a typo. Okay, so bullets x and bullets y are going to be very similar. I'm just going to copy that. We're going to change the y right here. As we know before, y value is going to be the sine of that degree. And so here this is going to be the same, and the same. And now here we have another thing that we need to add, and this is that dist to travel. So here it hasn't reached the point yet, and we know that because we've calculated the distance to that point. Dot dist to travel, if it's less than or equal to 0, we're there. Okay. Oh wait. So that's the next if statement. So here we're just going to say minus equals 15, because we have added this 15. This is the magnitude. So we're going to subtract that magnitude here. And so here, what we're going to do is we're going to say if bullets at I dot dist to travel is less than or equal to 0, what do we want to happen? Well, we want an explosion to happen. So we're going to say explosions. Now this is something we don't have, and we're going to add here in a second. Explosions.push, and we're going to add a new explosion. And this explosion is going to have basically an x and a y, and a radius and a type. Okay, so here this is going to be bullets at i.x, bullets at i.y, radius of 20, a type of 0, and we'll see that type here in a second. We're going to play a sound, so play sound. And this sound is turret explosion.ogg. OGG is just another file type for sounds, and so if you've never come across it, it's just like a wave sound, I guess, but I really don't know the exact differences. I guess it has a lot to do with how much of the original file is compressed down, how much is kept, and how much is lost, so the bit rate and stuff like that. I don't know. Just different compressions for sounds. And so here we're just going to say bullets.splice, and we're going to say I to 1 past I. And so basically just getting rid of the bullet that has exploded. And so this leads us to our next thing that we need to add. So we've drawn our bullets, or we are, and so now we want to push this explosion, or we want to play this explosion. But we do need this explosions array, and so we're just going to come up here and say let explosions equal. Okay, perfect. And so here, so explosions is going to be, it's a lot of kind of if and else's. And so if you skip this part, I would not fault you for that. But I just wanted to go into it just so you see the complete code. But this is kind of, it's not pretty. That's what I should say. So here we're just going to say function draw explosions. Now I could have had a sprite sheet that did this, but I couldn't find any sprite sheets I liked for explosions that kind of fit the bill and the look that we are going for. And so I just decided to create my own. Okay, and so here we're just going to loop through our explosions for let I equal 0 while I is less than explosions dot length plus plus. And then we're going to loop through the current frame of the explosions. And we haven't defined explosions yet, so maybe we should do that. So let's go up to the top where we have defined our bullets and stuff like that. And so right here, it looks like a good spot. And so up there, we're just going to say now there's not much to this. We're just going to say function and so explosion is going to take in a few things. It's going to take in an X, a Y, the amount of frames we want, and the type. Oh, so frames is similar to radius in that it goes for this many frames, but it's not exactly like a 20 pixels. If we say 20 frames, it doesn't convert to 20 pixels. It's some amount of pixels. So we'll see that in a second. Here we're going to say this dot X is equal to X. This dot Y is equal to Y. This dot frames is equal to frames. This dot type is equal to type. This dot current frame, because we need this new property, is equal to 0. This dot has exploded, has imploded is equal to false, because our explosion kind of goes in and then it goes back out. I thought it was a cool effect, so that's how I wanted to do it. We could have just done a very basic one, but I wanted to do a little bit different. And then this is going to say has imploded again, and this is going to equal to false. And this is going to be has exploded again. Now we don't need the has exploded value because that's just the initial value. So if you're wondering about that. Okay, so this is our function for explosion, and what we want to do is we want to go ahead and continue filling out that that draw explosions. So down here we have our draw explosions. Okay, so here we're going to loop through those frames. So here we're going to say for let j equal to 0. Well, for let j equal to explosions dot current frame, explosions at I dot current frame, while j is greater than or equal to 0, j minus minus. Okay, so we're going backwards here. And so here we're just going to say we're going to have a chance for the different color. Okay, so there's going to be two types of explosions. One that's red and orange, and another that's blue and purple. Red and orange is for our bullets exploding with an enemy, and blue and purple is the enemy exploding on the ground when it hits our planet or whatever it is. So let chance, and this is just going to be a map.floor. random times 2. If explosions at I.type is equal to 0, if chance is equal to 0, ctx.fill style. There's that shorthand. And then we're just going to say else ctx.fill style. Okay, and then here we're going to say, and then I'm going to go ahead and copy these two statements. And here this is going to be blue, and this is going to be purple. Okay, and so now that we have that, what we want to do is we want to draw our circle. So we're going to do ctx.beginPath, and then a ctx.arc, ctx.arc. So we're going to be drawing a full circle, and explosions at I.x, explosions at I.y, and this is going to be j times 2. So the current frame times 2. So this is actually, if we had 40 frame or 20 frames in this explosion, the actual explosion pixel amount would be actually be 40. So it's 2 times the frame amount. So here 0, and then here we have 2 times math.py. Okay, and then we're going to fill it in ctx.fill, ctx.close path, and then here we're going to check to see if it has exploded with any enemies. Okay, so here we're going to say for let k equal to 0, k is less than enemies.length k++, and then here we're going to say dist x equal to enemies at k dot cur y minus explosions at I dot x. And the dist y is going to be the same. So here we're going to say dist y. So this should be x. Cur x, and then this is going to be. And so here we're basically just going to say, well, is the distance. So we're going to get the distance, and then we're going to see if the distance is within the circle. Okay, so here we're going to say okay, and then we're going to check to see if that distance is less than or equal to j times 2. And explosions at I.type is equal to 0. So we want the explosion. The explosion is actually what's killing these enemies, and so we want to make sure that the explosion is the type for our bullet. Okay, so that's what that's saying right there. And so And if that's the case, we want to add to our score. Now these are variables we don't have yet, so we're just going to say score plus equals 10. We're going to give a bullet back to our player, and then we're going to get rid of that enemy from K to 1. Okay, so that checks that. All right. And so remember, we're still inside of explosions, but we're out of this second for loop. Okay, so here we're just going to be doing a lot of if and else statements that basically say, well, what frame is it on and has it exploded? Okay, so hopefully we can get through these. So here we're just going to say if explosions at I dot current frame is less than explosions at I dot frames and not and it has not imploded, then we're going to say explosions at I dot current frame plus equals 1. So we're going to advance the frame. Okay, and then here we're going to say and I think I can go ahead and reuse this right here, part of it. So if explosions is equal to and we have not imploded, what we want to do now, and let me go ahead and scroll up a little bit. We want to set has imploded is equal to true. Okay. And then so here we're going to do, might as well just copy and paste that. So has, if not, oh well, I guess we can't do that. Has exploded again. So this is going to be a not. If it has not exploded again yet, and current frame is greater than 0, then we're going to say has exploded again is equal to true. Okay, and so here we're just going to, I'm going to copy this because I think we can reuse this one. If current frame is less than explosions at I dot frames divided by 2, and has imploded again, okay, and has not imploded again, and then what we're going to do is we're going to copy that, and here we're going to say current frame is equal, and then has imploded again is equal to true. Now we're almost there. Okay, so here, and so these are else ifs. I just copied the else, but we can't just do that. So this is going to be an else if, And then here we're going to paste, and this is going to be an else if as well. And so explosions dot has imploded again. Okay. And explosions current frame is greater than 0. Explosions at I dot current frame -1. So we want it to go in. And then finally, we're going to say and this is going to be explosions at I dot, I guess I could have just, is equal to 0. We're going to splice that explosions dot splice I to 1. Okay, so I know that was quite a bit. So let's just go ahead. I know we need to add a lot to draw since we have not been adding anything to draw. So let's go ahead and look at what exactly we need to add. So we have our background, we have our player, we need to draw our bullets, we need to do our controls, we need to draw our explosions, and we need to draw. Okay, so we don't have, let's just go ahead and see what this does. I think we're going to get some errors, yeah, because I was trying to test it before we draw our explosions and stuff. But let's see if we can fix this. 182. 182. Oh, so this easily fixed. Okay, so not getting any bullets, but getting a lot of error messages. So bullet timer is not defined, so that's easy. So we're just going to go up to the top and say bullet timer is equal to 20. There's probably other issues, but let's just take them one at a time. Okay. And here we have 2 dest y, dest y. So that's at 57. Let's go ahead and pull that up. Okay. Let's see what that does. Source is not defined. Oh, 245. I know what that is. 245, and this is source. Getting closer. I know it just seems like we're going backwards, but so invalid token on line 55. And that's just, don't know how that got there. Okay, so I don't actually see the bullets, and neither should you. So let's go ahead and see what's going on. We have our draw bullets here, and we have draw bullets for let I equals bullets.length. Let's go ahead and just do some. So we have 3 bullets. I'm just gonna go ahead. The dy is undefined, and this is not a number, x and y. Okay. Bullets.degree is, let's see here, bullet dot deg is degree, so that looks fine. This dx and dy, that may be something that we're doing wrong. Oh, this is it. Okay. So here, just that. Alright, so now we're getting some explosion issues. Enemies is not defined. Okay, so that's exactly where we want to be right now. So now we want to draw our enemies. And so let's go ahead and get to it. Alright, so I'm going to apologize right now for the background noise. I had to turn on the AC in the sunroom. It's getting really hot here in Texas. It's like upper 90s, and so not fun. But let's go ahead, and what we want to do is we want to go ahead and draw our enemies. And so right now we don't have anything for that, but let's go ahead and get something for that. Okay, so we're getting really close. Okay, so we have two functions left to create, and they're relatively simple functions. Okay, so here we're just going to say function draw enemies. Now we don't currently have any enemies, okay, but our enemies are just going to be a line, so it's going to be super easy to finish out this, and then we'll create something that actually creates those enemies. So here we're just going to do a ctx.line width. We'll set equal to 4. You can change that as you wish. So for let I equal to 0, while I is less than enemies dot length. Okay, so here we have ctx dot begin path, ctx dot stroke style, and then we have our actual drawing the line in JavaScript, and that's consists of a ctx.move to, and so here is going to be our enemies at I dot cur x. Okay, and then we're going to line to. So this is the second statement for drawing a line. So we're going to say line to, and this is going to be init x and init y. So this is initial x, initial y. Basically, this is going to be a streak across the sky that doesn't end until it actually explodes with something. So ctx dot close path, ctx dot stroke, we're going to update our cur y and cur x. Okay, and so this is going to be 90 times math.py divided by 180 times 2. Okay, and then this can be, we can just go and copy this, paste, this is going to be x, this is going to be y. Like we said before, this is going to be sine, and everything else is the same. So this is the speed that they're going. So if you want to make it faster, you could change this to. We could actually make this a variable and call it enemy speed, and set that up at the top. And if it were a variable, as the time progressed, maybe the enemy speed could get faster and faster, and that might make the game a little more fun. And then the last thing is we're going to say if enemies at I dot cur y is greater than or equal to 600. We're going to push another explosion. Enemies at I dot cur x. Enemies at I dot cur y. 20 and 1. If you wanted to make those explosions larger, just change this number, okay? But I think they're good where they sit right now. Okay, so the next thing that we probably want to do is make a sound when it explodes. So we're gonna play sound, and this is gonna be a ground explosion dot wave, and then we're gonna remove that enemy. Okay, so we still haven't added enemies. Okay, so this is drawing any enemies that are added, but none have been added. So what we're going to do is we're just going to create a little chance function right here that says a chance math.floor math.random times 100. So there's a 1% chance that it will happen at any one frame, whatever this chance is. And then we're going to say if let ix equal this should be math.floor, and here copy, and this is going to be dest x and so the initial y is going to be the same. The initial y, which we have not defined here, is just going to be 0. It's going to be at the top of the screen. The destination y is going to be 600 at the bottom of the screen. Okay, so that's where those numbers are going. So here we're just going to say enemies.push, and we're going to say new enemy ix 0 dest x 600. Okay, and let's go ahead and see. Oh, we don't have enemies defined. We're going to get to that in just a second. Alright, so let's go ahead and define this enemy. So go up to the top right up here, and we could probably just do it under bullet or explosion or whatever. Let's see here. Where is this enemy at? Draw background, explosion, and then we have this function enemy. And here we're going to have our init x, init y, target x, target y, So here, what we're doing is just figuring out how much of a rotation it is between like the initial X and where our target is, and so that's going to be our rotation for the bullet. Okay, so here we'll just say init Y, target Y, and here we're going to say this dot rot is equal to -1 times math dot atan 2 adjusted X adjusted Y times 180 divided by math dot pi plus 180. All right, and so this looks good. I don't see any. I can't think of anything else that we need to add code to. So let's just see what kind of errors we have right now. So right now we have unexpected token on 49. So 49 is going to be right here. Done that before in this very video. Okay, so far so good, and we get an error. Okay, and here enemies is not defined. Did I not define this? Star. And so, yeah. Okay, so where we left off was we didn't have enemies. That's just going to be equal to a blank array. So let's go ahead and run this and see where we're at now. Okay, this is an issue, and we get no enemies. So let's go ahead and see. All right, so maybe it's because we're not calling draw enemies, but we also have this going on. So let's see what that looks like. So down here, yep, no draw enemies. And then the draw explosions, they should at least end at some point. So let's go up here. If explosions, I just got to make sure all these steps are right, because we only have one minus here, but we have other steps. So let's look at that. Yeah. Okay, so it looks like right here, this should be a minus. Actually, you know what? It looks like we're missing a step. Okay, so here we have our +1 true, and then we needed a, so it has imploded, and then we needed a negative. So I'm going to copy this, and this should go right here. So, and what this should look like is, and I'm just going to paste it in. So if explosions at I dot has exploded again, but this is not. So if it has not exploded again, and explosions at I dot current frame is greater than 0, we want to do this. Then we want to set it to has exploded again. So let's look at this. Okay, that doesn't help us out at all. But okay, score is not defined, but we also have this issue. So let's look at that. Okay, so like I was saying, we had this was just a second ago looking like this, and I just go ahead and change this to minus equals 1. And so this is a line that we just added a second ago, but I missed this little part to it. So let's go ahead and see what that does. Alright, looks like it's still not retracting. So score is still not defined. Okay, so that, let's just, alright, so that's no good. Let's go ahead and keep on looking. So current frame is greater than 0, and then if current frame is equal to 0 and has not exploded again, I think that might do it. Every time we find something, we get a little closer. So here, explosions has exploded again. Current frame is... Okay, so I do see one issue here. It looks like, you know, we forgot to add the explosions at I. This is not, it doesn't know what this is. It'll make it up, you know, JavaScript does that. And so you have this variable right here that doesn't mean anything anymore. But we care about the explosions that I has imploded. So we're going to check this out. And right now yours may not be working because our... Okay, so that looks good. I just added a quick score at the top, and we can go ahead and do that. So right here, let me go ahead and turn that off. Right here we have let score equal 0, but we're going to add a little bit more. We're going to actually create the draw score function, and so let's see here. Let's see here. Draw score is going to be a very easy little function. All right, so right here, right above draw, and we're just going to do ctx.fill style. Now there really is like no real logic to this as far as like what these colors represent or anything. So you can make these draw score colors whatever you like. Right now it's like red and green. What is that? Blue? I don't know. And then red and green. What do red and green make? Is that a, I don't know, yellowish? We'll see. And then the ctx.font. And here we want to make it a bigger font, so we're going to say 18 pixels with that font style. And then ctx.fill text. And we're going to say score. We're going to add the score that we had just created at the top, and we're going to draw it to that location at 700 for the y, x, and then 25 for the y. And then we're going to do a ctx.fill text, and we're going to tell the player how many bullets they have left. And we'll draw this directly under the score. Okay, so we have this draw score right here. We're just going to go ahead and paste it down here. And So this is what I see right now. And let's go ahead and see what happens. All right, so it looks like an easy game, but you start to have issues when you're trying to guess where they may show up. And so if you are looking at this, you see the bullet, it's coming from the bottom of the turret. And so we don't want that. I'm not buying some dishes. I think I broke one of my wife's plates, and I think I have to, but it's like an old plate. So I was trying to see if I could find it, but no luck. Anyways. So here's the thing, we made one small error over here. So player Y is at the top of the turret, and that's where we want the bullet to appear. We don't want it to appear further on down, okay? So we're just going to take that plus player height. And let's see, I'm just gonna go ahead and mute this real quick. Okay, and now we get the proper behavior. Before it was playing at player height divided by 2, so like right here, because this is the player. And so it was shooting from right here, but now we want it at the top of the turret, which is all the way up here. Yeah, so this is basically it. There's a lot more you can do to this. You can add stages. You could just make it progressively more difficult as time goes by. You could make it so that there are different color enemies that come down, and if you shoot some, you don't get bullets back. You could make it so that there is ground down here, and when all your ground has disappeared, your game is over. And I think that would actually be even more interesting. You're trying to protect your ground, but you know, when it's all gone, you know, there's no point anymore. So there's lots of ways that you could extend this game out. And so you could make this something that would be really cool. There's lots of cool math in this game that you could apply to lots of other games. So I hope you learned a lot, and I'm just going to say it again. If you enjoyed this, I have some other stuff coming down the pipe that, you know, if you watch Zelda and the Street Fighter tutorials, those are games that will take a long time to finish. And so a lot of people don't have that kind of attention span for games. And so I'm looking to add a lot more, a lot shorter games, so that you can still learn a lot, but you can get it done in just like an hour or two. So or even less. Like for something like a basic tic-tac-toe that you can play against the computer or something like that, we could probably finish that in a lot less time. But yeah, so I'm looking to kind of change the format, create a lot more shorter type tutorials. But if this is something that you're liking, click subscribe and like the video, and I can go ahead and do this a lot more in the future. So I hope you enjoyed it, and I will see you in the next one.